Cool. Hi, everyone. I'm Davide.
And I'm Neal.
This is the Hyperscale SIG update. We've been giving versions of this talk before at various conferences. Next slide, please. We'll go over a quick recap of what the SIG is about and what we do. We'll talk about what we've made recently and what you can use. And then we'll have a few words on what's coming down the pipe. Slide. So the idea behind Hyperscale is to have a place where people and companies can work on improving CentOS for large-scale infrastructure deployments. It is a SIG that's entirely focused around CentOS Stream, and the idea is that a lot of people that have large CentOS deployment end up building kind of the same tooling and working on often the same packages, and wanted to have a space to bring all of this development out in the open instead of having it closed behind closed doors. While there are members from large companies in the SIG, it is by no means restricted to large companies, and anybody is welcome to participate if they would like to do so.
Right. And so we started this, oh, come on, refresh over here. There we go. We started the SIG in January 2021 with CentOS Stream, focused on CentOS Stream with 6 founding members, myself, Davide, and a few others. As of now, we have 35 members and we're growing. We primarily operate within our matrix room, CentOS Hyperscale, and on the Fedora project server, and we have bi-weekly matrix meetings. In addition to that, we have monthly video hangouts where we socialize and also maybe hack on things together. And we do meetups, usually attached to some other event, like the upcoming CentOS Connect. You should sign up for that when it becomes a thing, or other events like Scale or Flock or whatever. There we go. Okay, and for the SIG itself, we have our charter and other pieces of information related to how our SIG is formed and what we do, as well as user documentation about the stuff that we produce, which we'll get into in a bit, about the stuff that we make as part of our work. We also provide regular activity reports, I think on a quarterly basis, as well as things like this conference talk, which we give in all kinds of places. You want to go see all the other stuff we've talked about, and you can see the kind of things that we're working on, as well as stuff that, if you want, issues that people bring up and whatever, they're also in our issue tracker. Okay, this is very annoying. All right. Davide, you want to take this?
Sure. So now let's talk a bit about what's in the SIG now. And we'll go over all of these, but we have package backports. We have packages that provide policy and configuration alternatives. We have packages that allow us to use the SIG for large-scale testing. We have a kernel, we have spin images, and we have cloud images. And we'll go over these in a second. Next slide, please.
Yes.
So let's talk about backports. The idea behind backports is to have packages that are drop-in replacements for packages provided in CentOS Stream, in CentOS Stream 9 or in CentOS Stream 10, but that for whatever reason cannot be updated in the distribution itself. So we provide a more recent version in the SIG. Usually it ends up being a backport that's straight from Fedora, but sometimes it could be a rebuild of the CentOS package with a few patches cherry-picked. We build these and require EPEL to make life easier for everyone, because often you need packages from EPEL to build packages. Also, it's very rare to have a CentOS system that is useful without EPEL, so we might as well just pull in EPEL anyway. We only build these for x64 and ERC64 because those are the only architectures we test for. If somebody is interested in doing this for Power or for S390, we technically have the ability to do so in CBS, but nobody in the SIG cares about that. But if you do and you would like to join the SIG and commit to supporting those, that would be fantastic. There's a list of a handful of packages we added recently, but this is kind of all over the place. Often it ends up being bits of packages, especially in low-level system user space, that is useful to have. Sometimes it's developer tooling. So for example, we have things like backports of Vim and Emacs, because people like having up-to-date editors. Or the most recent one I added was Vine, because we found that there was a memory leak of sorts in the version that was patched in Stream, but that didn't present in the one in 10. So we backported the version for 10 in the meantime while we figure out what's going on there. You can see the whole list there for both 10 and 9, and we'll talk about 10 later. We also have an in-progress effort about QEMU and virtualization, which we'll talk later, and we have an in-progress effort around OpenSSH. The OpenSSH stuff is kind of interesting. So I work at Meta, and at Meta we have a deployed internal version of OpenSSH with a pile of patches of questionable quality. And we've been slowly working through that to figure out which ones are actually useful and which should be upstreamed. And as part of that, we started the actually useful one with building them in Hyperscale so that they can be more widely tested. And this package isn't built, isn't tagged in the release, in the public release yet, but it is there if you want to play with it. We don't quite want to unleash this to the real world just yet. Next slide, please. The other thing we do is we have a pipeline for tracking whenever packages need to be updated, because sometimes you'll do a backport, but then the stream would rebase, and then your backport is out of date, so you have to decide what you want to do. Sometimes you get rid of the package, sometimes you have to port the patch you have. This runs in OpenShift. These actually could use some work now, because we haven't tested it in a while, and I think it's not in the best of shapes. So if you like working on OpenShift, this could be a fun contribution project. It leverages the MQTT feed that comes out of stream, which is quite useful. If you don't know about this, there's an MQTT feed you can subscribe that tells you all things happening about packages in the distribution. So that's quite handy to get signal whenever packages are built or added or things like that. Next slide, please. So one notable backward we have is systemd. And we care a lot about systemd at Meta in particular, because we do a lot of upstream development in systemd. And we didn't want to have to constantly cherry pick patches and try to backport them on the stock version. So we packaged in the SIG the very last upstream release, which right now is 2.56 and will be 2.57 when that comes out. We built this for stream 9 and 10. This makes a few differences from the stock one. It defaults to SIG of 2, which is now, I think, the default. Yeah, it's definitely the default in CentOS as well, but it didn't used to be the default in 8. We also enabled all of the additional daemons that are shipped in systemd. So we have systemd UMD, we have networkd, we have resolved, we have journald. These aren't turned on by default, but they are available. So if you want to use them, you can use them. It should also work all right with SE/Linux, but we don't test SE/Linux a ton. So if you find bugs in the SE/Linux integration, that would definitely be appreciated. I would expect in general the core daemon should work well with SE/Linux, but some of the more fringe ones might have some trouble here and there, because this is a very wide policy. Next slide, please.
There we go.
Yeah, that's fine. And we have a repo that we use to track development and stage patches. We've actually been trying to steadily move towards just using the Fedora package and contribute to anything we do in the Fedora package. I think we're almost there now. In the builds we did, at least for 2.56, are like
we're very close.
Yeah, they're not identical because we have a few gates here and there, but they're almost identical. The delta is very, very small. We have a CI on GitLab where we do automated builds of these. And one thing we do that is especially useful is that we'll do daily rebuilds of the latest Git main from systemd as if we were building the package today. And this gives us quick signal on whether a change was committed upstream that could potentially break in stream. And then we can work with it in upstream or on our end, depending on where it impacts. And we have docs. We have surprisingly good docs around systemd that you can read if you're interested in doing this work and contributing. Those are all available there. Next.
There we go. Yeah, so on top of the stuff that has been done with systemd, we've also in the past provided Intel optimized packages. This was a contribution from engineers at Intel to enable usability of newer CPU features to enhance the performance of compression functions, as well as some other things with cryptography and things like that. So there was zlib backports, there was glibc stuff. These were API and ABI compatible. This content has actually been upstreamed into CentOS Stream itself now, as well as into Fedora Linux. So the transition to zlibng was partly driven by this, as well as some of the work that has been done in glibc to optionally take advantage of new features in CPUs. This stuff it still exists in our Hyperscale Intel stuff, but it's been largely superseded. But it's a good example of how we were able to work to onboard people into the community and bring them into a position of being able to contribute to the benefit of the whole ecosystem and community at large. In addition to this, we're talking about contributions to CentOS Stream in the community. Let's talk a little bit about Hyperscale and its contributions to CentOS Stream. So primarily, we focus on CentOS Stream now. We've phased out CentOS Stream 8, and we are ramping up on CentOS Stream 9, which I'll talk about in a minute. As part of CentOS Stream 9, we've done a lot around contributing to the distribution. Notably, like we enabled the optional usability of systemd UMD by providing default configuration and subpackaging for that, enabling the ability to package up and use third-party Nginx modules with the system Nginx package in CentOS Stream. The transition to Pipewire with Wire Plumber and enabling Jack compatibility in CentOS Stream 9 was a contribution from the Hyperscale. We also did work around Wayland enablement and improvements around the GNOME Wayland environment. And there's some miscellaneous packages here and there that we had updated. I think notably the ETH tool 516 rebase that was done by Davide was a Hyperscale contribution to support being able to work with newer network cards and compatible with upstream enablement from the backporting of newer features in the network subsystem into the RHEL kernel. Okay. And so I mentioned about CentOS Stream 9. Now we're talking about CentOS Stream 10. So we've started working on CentOS Stream 10 at the beginning of this year, and we've got some initial features contributions. We've done some improvements to the branding packages, particularly to enable to offer the correct logo artwork for bootloaders and login managers and things like that. We've also updated libportal to the latest version, 0.81, and enabled Qt6 support. So applications that use libportal to access the Wayland portal infrastructure are now able to be built against CentOS Stream 10. So in EPEL in particular, like this will enable things like input leap, desk flow, and a few other things here and there. Of course, the standard Wayland updates. We work, updating Wayland protocols, Wayland libraries, that sort of thing. We added some packages to the CRB repo, libdisplayinfo, and the libei packages towards enabling KD Plasma in EPEL and in Hyperscale Desktop. We also did some work around enabling AR64 targets for the Rust compiler. That's related to some future work around ARM that we're going to talk about in a bit, as well as backporting some fixes to dwarves to make it work properly with Clang. We've also done some small fixes to install dependencies, particularly around CA certificates, to make sure that when you install the package and the programs that run in the scripts are executed, that they actually have everything that they need to run. But I will hand this back to Davide to talk about the large-scale testing stuff.
Yes, as I mentioned, another thing that we want to be able to do in Hyperscale is to test wider changes that encompass the whole distribution. So a good example here is the work we're doing with DNF and RPM copy on write. If you're not familiar with this work, we have a patch set on top of the packaging stack around RPM and DNF that makes it leverage copy on write features offered by modern file systems such as ButterFS. And long story short, this makes package installation faster and more efficient. We do run this in production at Meta, and it works, but it had kind of a storied history in terms of upstreaming. It went through several rewrites because it touches so many components. And because we wanted to have a way to test and deploy this easily, we decided to build this in Hyperscale in its own dedicated repo, which we call experimental. So it's not enabled by default because it changes the behavior of the system, and it's not something you might necessarily want to have. But if you do want to have it, you can enable this repo, and then this will allow you to install this modified packaging stack that is hopefully more efficient and works best for you, and it can provide a good experience, and you can also use it to provide us feedback on how it's working. We added a few links there. The very latest version of the code, if you're interested, is the last one on Matteo's fork. We're hoping to make another effort at upstreaming this in the coming months. Next slide, please.
Yeah, so in addition to the work that's being done with RPM copy and write and a lot of the user space backports and modifications, we actually maintain our own kernel for this. So we currently are on a 6.11 kernel based on the Fedora kernel with a relish config. The main differences is we enable Btrfs support, we enable BinderFS for being able to use Waydroid, and a few other things here and there. This is built for both CentOS Stream 9 and CentOS Stream 10. At the moment, it is in the experimental repo primarily because we don't have secure boot support. The effort to support secure boot for SIGs is still outstanding. There's the link. We'll see.
We'll get there eventually.
We'll get there someday, hopefully. As part of doing the work, in the past we were based on the RHEL kernel, and when we were working on the RHEL kernel, and even afterwards, we still do some collaboration with the RHEL kernel team. But the notable ones for CentOS Stream 9 is we helped uplift Z standard to the latest version. We enabled Blake2B crypto functions and some various build fixes here and there. This allowed us to work with the KMod SIG for a time to be able to offer a kernel module for offering Btrfs on stock CentOS Stream and RHEL systems. This was a great example of us being able to work with multiple stakeholders to enable successful deployments and contributions for people within the community. And if I can make the thingy actually move, I don't know why the focus thing doesn't work the way it's supposed to, but it's okay. It's fine.
That's all right.
With kernel user space stuff related to the kernel, we have, of course, the user space for Btrfs backported. Btrfs support is restored in the installer. This is currently at 6.7. The plan is when I get around to it to start working more on the CentOS Stream 10 spin stuff. This will be uplifted to the latest version, probably matching whatever we ship in the kernel. And so we do all that so that we can have like a fully fleshed out user space for people with the both installing an image as well as being able to work with it on install systems. In addition, K-patch is shipped, which is essentially just a rebuild of it that doesn't strip out K-patch build with some backports for profile guided optimization and a few other things here and there. And I wish this would work. So, Davide?
We also have container images that can be handy if you want to quickly test or if you want to build your own container images on top. The one for Stream 9 is there. I don't think we have one for 10 yet, but we should probably start looking at making one now that there's images for 10 as well. The 9 one, the 9 image is built from scratch. It doesn't inherit from the stock one because of technical limitations. We'll see if we need to do that again for 10 or not. But these are built in OpenShift, like some of the other artifacts, and the repo for doing the build is there. It just uses a standard pipeline with build that. But this can be handy, and they're hosted on Quave. Next slide.
All right.
Oh, that one's yours.
Yeah, it is. The live media stuff. So I alluded to this a little bit, that we produce spins, and as Davide mentioned at the very beginning, that spins are a part of our artifacts. So we produce live media spins. Currently for CentOS Stream 9, we produce 2, one with GNOME and KD Plasma. These are live DVD ISO images with hyperscale repos and packages. It leverages our kernel with Btrfs support. You can download it and report issues and all this stuff. This is essentially a collaboration with the Alternative Images SIG, where we leverage the same technologies and strategies, even if we're putting together slightly different content sets. A lot of the work that we did in the very beginning for Hyperscale's live media actually was used to bootstrap the Alternative Image SIG for people who wanted to also combine CentOS and Apple content to provide interesting experiences or different desktops on top of the stock CentOS thing. And it's a really great, the opposite direction. Like when I mentioned earlier about Intel, where we brought people in who went inward, this is one where we were able to start in and spin outward into creating a whole new sub-community, which has been really nice to have. So now we have more opportunities for people to engage and be part of the CentOS community. And, with all the other stuff around CentOS Stream 8 being phased out, we also don't have the CentOS Stream 8 spins anymore. Those were built with Live CD Creator. The current ones for 9 are built using Kiwi, and the 10 stuff is also going to be built with Kiwi. This is also one of those things where we outflowed into Fedora as well. The work that we did in CentOS Stream actually influenced the work that was done for Fedora Cloud, as well as Fedora Asahi and all these other things. And that'll all come back full circle really soon. So on top of the live images, and I mentioned about Fedora Cloud and such, We also produce cloud images. Right now, 2 of them, one for generic cloud environments or OpenStack optimized environments, and one for Amazon EC2. These are like the live media, they're built with Kiwi. Again, the same deal as before. Eventually, we're going to produce these for CentOS Stream 10 as well, as we get more and more content in place between CentOS Stream and Apple. Like the live images, you report them all in the same place. Easy place to find them. So, Davide?
Now let's talk about what is new and what happened lately. We talked a few things about CentOS Stream 10. As Neal mentioned, we are already building content for 10. We already have package build pipelines. We're slowly adding things. The content set for 10 is going to be smaller than the one for 9 because a lot of the packages in 10 are already up to date. So there's no reason for us to backward them unless we have to. But we expect it will slowly increase. And likewise, we will have spin images as well and a kernel and all of that eventually. And we already have a kernel, actually. We will have spin images in due time. The other thing that's new is the visualization stack, where we now have a backward of the visualization stack. So Kimu, libvirt, libguestfs, and so on. In Stream 9 and eventually in Stream 10 as well. This is based on the Fedora packages. It includes a number of bug fixes and improvements. It also restores support for a bunch of features that aren't available in the stock packages. It is something we're running in production at Meta, and hopefully it can be useful outside of there as well. Finally, the last recent news is that we have joined membership in the Linux distros list. Linux distro is a private mailing list that provides advanced notification of security vulnerabilities. We joined this because we effectively ship a lot of packages that have versions that deviate from CentOS Stream. So we wanted to be sure we could provide security fixes timely if the need arises in a way that would be beneficial to users. So we're now able to get notification for CVEs ahead of time, so we can ideally coordinate response when the need arises. Next slide. Oh, we're doing a really good time.
Yeah.
So as we mentioned, coming up, we'll have spin images for 10 for Hyperscale. We also started the early effort of porting CentOS Stream Hyperscale to Apple Silicon hardware. Neal and I are involved into the Fedora Xi remix work, which released the port of Fedora for Apple Silicon in collaboration with the Xi Linux project. And we like to do the same for CentOS Stream because we think CentOS Stream is a really good platform and can be useful, especially if you want to deploy a server workloads, for example, on like Mac Minis or Mac Studios. It would be well suited for that. So expect to see some announcement on that, hopefully early next year. We'll see. Right now, we're still in very, very early stages. We're also doing work, well, Neal specifically is doing work on being able to provide composes and compose-like artifacts for C contents, where the idea is that we can have an artifact that looks like a compose, so it looks like the distribution compose for the content that comes from Hyperscale that can then be paired with a CentOS Stream compose and with an Appel compose. So you can have a unified set that people can qualify against and test against as a unit, and it can be referenced as a single thing. We also still would like to eventually get an updated Kimu package in Appel, although that hasn't really seen a ton of work lately. We did do all of the work for the prerequisites for that, for the Appel, for Kimu itself is still there. And finally, we still have a long-term goal of getting Btrfs transactional updates going in some form or another. I believe that's all we had. Next slide should be questions. Oh, no, resources. Yes, you can find us. Find us on the docs, find us on Matrix. Feel free to join one of the meetings. You don't have to be a member of the SIG to join the meetings. You're welcome to lurk. You're welcome to introduce yourself and say hi. You're also welcome to stop us at conferences and say hi if you'd like. We're always happy to talk to people. We have an issue tracker, which is a bit of a mess right now, and we need to clean up. And we are also on the CentOS mailing list, of course. With that, I saw a few pop-ups earlier. Let me see if I can open the thing and see what the questions actually are.
I see one at least. So someone asked here that maybe I misunderstood something. Btrfs is an option. As far as I knew, RHEL 10 will not support Btrfs installations. Can you elaborate on the matter?
Yes, that is correct. Stock RHEL 10 does not support Btrfs, but we do support Btrfs in Hyperscale. As Neal mentioned, we ship our own kernel, and in our own kernel, we have Btrfs enabled. Our own kernel is based on the Arc kernel in Fedora with a rel config. So it's effectively, it's a more up-to-date kernel than the kernel in rel. It has the same feature set as the kernel in rel, plus extra things we add. And one of the extra things we add is Btrfs support.
Right. This does have a little bit of an interesting flip side here, right? So because we ship our own kernel, even though we present similar features and the user space API is stable because of that, as in they're consistent between rel and CentOS Stream. CentOS Stream's user API for Hyperscale should be, strictly speaking, a superset of what is provided in the stock CentOS Stream kernel. It means that we do not share the kernel API, which means that kernel modules that are built for stock CentOS Stream, such as for the KMod SIG, do not and will not work on the Hyperscale kernel. So if there's a feature in there that they provide that we don't, that's a conversation to have with us to see if we can turn it on. Because unlike with the KMod SIG, where they're basically building modules that don't exist in the rel kernel, but that people still want, we can just turn them on and add them to our kernel builds. So,
yep. It's also worth noting that you don't have to run our kernel. And as we mentioned earlier, the kernel is actually shipped in the experimental repo. So you can definitely run our user space with the rel kernel if you so desire.
We do take care to make sure that that stays working.
Yep. And in that case, you obviously won't have Btrfs. Any other questions? I think that was the only one.
That seems to be the only one I see.
Okay, then. Well, thank you, everyone.